So halogenation is adding a halogen and another halogen. So here we're adding 2 bromines or 2 chlorines across an alkene. Halogenhydrin is a halogen and a hydroxy being added. So first we're going to talk about halogenation. I mentioned bromine and chlorine. We do not see fluorine because it's too reactive, it causes explosions. And we don't see iodine because iodine is just not reactive. So bromine and chlorine are in the sweet spot. The addition is anti instead of syn. So if one is added in the up position, the other would be added in the down position. The mechanism is down here. The bromine is here. The nucleophile, in this case the pi electrons, will induce a temporary dipole in the nonpolar bromine molecule. Okay. Then there'll be a nucleophilic attack, so the electrons in this bond attack the bromine, and there's a leaving group. Loss of a leaving group, the other bromine leaves, and you end up with this bromium ion, this bridge. The next step is a nucleophilic attack. This bromine is sitting on top of the molecule, and it blocks top attack, or it blocks attack from this direction. Blocks attack. So the bromine that's going to attack has to attack from the underside, which it does. And you end up with an anti-addition. One is up and the other is down. And you also then get the enantiomer of that. The results of this reaction depend on the starting alkene. So if we start with a cis double bond, and we add one of our bromines up, the other bromine gets added as a dashed line away from us, and we have this. We also have the other possibility. Now when I look at these two, I was tempted to say, oh, they're the same. But they're actually not. They're mirror images of each other. And there is a video with me playing with the models to convince myself of that. So if we start with a cis, we'll end up with a pair of enantiomers. If we start with a trans, we'll end up with something that looks like this. One will be up. The other, of course, is down. If we rotate this, we end up with a structure that looks like this. And so with the trans, we end up with this meso. This has symmetry, so it's meso. And we end up with a meso compound, and so they're the same. And like I said, there's a video with me playing with the models to show you that they are indeed the same. So let's see what the major products would be. So we're going to add bromine to this position, and we're going to add a bromine to that position. One of them is going to be up, and the other one's going to be down. And then we can't forget that we've got these methyl groups here. So the methyl groups, put them on 2. And with this other molecule, we're going to have the methyl group will be up and the bromine will be down. The methyl group will be down and the bromine will be up. So let's add to here. We're going to add a bromine here and we're going to add one there. So we will end up with a bromine in the up position, and we'll have, this will end up being a dash, and we'll have, I did that, okay. So that's in the up position, so this bromine has to be in the dash position, and the methyl group here is on a wedge. Other possibility is that this methyl is on a dash. That makes this, that bromine on a dash. So it makes the other bromine on a wedge. And so the methyl group has to be on a dash. Okay, so one bromine is up, the other bromine has to be down. And we just want to do both possibilities. If we look at this one, we can put the bromine up, and over here we'll just have a bromine. We don't have any stereochemistry. This is not a chiral center. And on this one, we'll put the bromine on a dash, and here we just again have a bromine. All right, so if we want to have a halohalogen, if we would like to add our bromine and we want to add a hydroxy, this will be added in a syn addition. Bromohydrination is adding a bromo and a hydroxy, or you can add a chlorine. And a hydroxy. So the mechanism is the same. The halogen reacts first, blocks the top of it, and so you end up with one of them being up and the other one being down. But now we have two different groups, so we need to determine where that hydroxy is going to go and which atom is going to get the bromine. And the answer is that the hydroxy is installed at the more substituted position, because the more substituted position is better able to bear the partial positive charge of the transition state. So here is our mechanism. The pi electrons attack the bromine attacks the other carbon. We've got a carbon here and a carbon here, and we have a leaving group. So we've got our transition state here, and we're going to need to put a water molecule, not a hydroxy. We're going to be adding water. And this more substituted position is better able to manage having this positive charge nearby. So let's look at the major products when we treat with bromine and water. So here's our double bond. I'm going to change color so we don't have it green. Here's our double bond. So we're going to have to add something here and something here. This second one that I drew is the more substituted position, so that's the one that's going to get the hydroxy. So let's put the hydroxy here. I'm going to draw it on a wedge. that means that this must be on a dash, the ethyl group there. If the hydroxy's on a wedge, then when we put the bromine on, we need to put it on a dash. So one's on a dash, the other's on a wedge. Okay, so here we're going to do just the reverse. The bromine goes on a wedge, and we're going to put the hydroxy on a dash, and then we'll have to make this on a wedge. Okay, so then let's look at this other one. We're going to have to add to here and to here. This one is more substituted, so it's the one that's going to end up with the hydroxy. So let's put the methyl group on. One of them will be a dash and the other one will be a wedge. The hydroxy is going to be a wedge here. If the hydroxy is a wedge, then the bromine must be a dash. So if the hydroxy is a dash, then the bromine must be a wedge. Bromide ions can be captured by other nucleophiles, so it doesn't have to be water. So what if it's ethanol instead? Then we would get this. Again, one of these would have to be, that's the methyl group. One of them will be a wedge and one of them will be a dash. And instead of adding a hydroxy group, we'll add, I'm going to change colors here. We're going to add a dash, ethoxy group, or a wedge, ethoxy group. Now, if the ethoxy group is on a dash here, then we'll have a wedge for our bromine. And here we'll have a dash for our bromine. Okay, and we'll do exactly the same thing here. And we'll dash. And this would be, if that's a dash, then this has to be a wedge, because this is an anti or a syn addition. And so, oh, didn't do it, it did a dash. Okay, so this is a wedge up here, and we've got a dash down below.